Dear students, welcome to another session of eShikshana program. In the last class, I discussed on one of the predictor and character method, Milne's predictor and character method, which is a multi-step method which involves a sequence of previous values to compute the value of y at the next specified value of x. So this sequence of values, if it is not given in the problem, can be obtained by the single step methods which we discussed earlier, either by Taylor series method or by Runge-Kutta method of fourth order or by Euler's modified or Euler's method. Let me consider one example in which we need to calculate the sequence of previous values and then compute the next value of y at a specified value of x using Milne's predictor and character method. Okay, so let me consider a problem. So this is the problem. Determine the value of y at x is equal to 0.4. Y of 0.4 means at x is equal to 0.4 using Milne's predictor character method. Given that dy by dx or y dash is equal to x into y plus y square with initial condition y is 1 at x is equal to 0. Use Taylor series method to get the values, the previous values of y at x is equal to 0.1, y at x is equal to 0.2 and y at x is equal to 0.3. So let us first apply the Taylor series method to find these values of y at x is equal to 0.1, x is equal to 0.2 and x is equal to 0.3 with the help of the given initial condition. Y is 1 at x is equal to 0. So the solution part, what is given, let us write down first. Solution. We shall write down what is given here. So given y dash is x into y plus y square. X naught is your 0. Corresponding value y naught is 1. Y naught is 1. The next value is 0.1. X is 0.1. The corresponding value we have to find out first using Taylor series method. And similarly, x2 is 0.2. And corresponding value y2 we need to calculate. x3 is the next value, that is 0.3. Corresponding value y3 I need to find. That using the Milne's method I have to find the value of y at x is equal to 0.4, that is y4 need to be calculated using Milne's predictor and character method after finding y1, y2, y3 which is required to find y4 by the Taylor series method. Okay, let us apply first Taylor series method. So let me write down the data here. Y dash or dy by dx. Y dash is x into y plus y square. Then x naught is 0. Y naught is 1. Y naught is 1. Next, x1 is 0.2. Then corresponding y1 we have to find out using Taylor series method. x2 is 0.2. Corresponding value y2 I need to calculate. Then x3 is 0.3. Then corresponding value y3 I need to calculate. Then x4 is 0.2. x4 is 0.4. Corresponding value y at x is equal to 0.4 need to be calculated using Milne's predictor character method. So from Taylor series, h, what is h? H is point, this is point 1, x1 is point 1. Point 1, point 2, point 3, okay. So now h is 0.1. H is 0.1. From Taylor series, we have y n plus 1 is equal to yn plus h divided by factorial 1 into yn dash plus h square divided by factorial 2 into yn double dash plus h cube divided by factorial 3 into yn triple dash. Yn triple dash. This is h cube into yn triple dash, etc. Infinite series, etc. So now let me first calculate the derivatives. I need to substitute at these places. So let me calculate the derivatives. Y dash is given. Y dash is x into y plus y square. So let me differentiate this with respect to x to get y double dash. What is y double dash? Product of x into y dash plus y plus 2y into y dash. So this is x into differentiation of y dash plus 1 into y, differentiation of x is 1 plus 2 into y into differentiation of y, 2y y dash. So I need third derivative also. So y triple dash, again product rule here, x into y double dash plus y dash plus y dash plus again product rule. So 2 into y double dash plus 2y dash square. 2y dash square. Okay. 2 into y, differentiation of y dash, y double dash plus 2 into y dash into differentiation of y dash. So 2 into y dash square. So I can club these two. So y triple dash is x into y double dash plus 2 into y dash plus 2 y double dash plus 2 y dash square. Okay. So let me put, so I need this. So I just put a line here. Now call this as equation number 1. Now to get y1, I have to fix n is equal to 0 in 1. So put n is equal to 0 in 1. Put n is equal to 0 in the relation 1. So y1 is equal to y0 plus h divided by factorial 1 y0 dash plus h square divided by factorial 2 y0 double dash plus h cube divided by factorial 3 y0 triple dash and so on. So what is y0 dash? Let me substitute for y0 is 1, but what about y0 dash? So y0 dash you can obtain from this relation, y0 double dash from this relation, y0 triple dash from this relation. Okay. So put, so therefore y0 dash is x0 y0 plus y0 square. Now substitute for x0. x0 is 0. So 0 into y0. y0 is 1 plus y0 square. 1 square is equal to 1. So y0 dash is 1. So similarly, Similarly, y naught double dash. Y naught double dash is x naught y naught dash plus y naught plus y naught plus 2y naught y naught dash plus 2 y naught dash plus 2 y naught dash. Okay, now substitute here. So this is equal to, so this is 0, y naught dash is 1 plus y naught is 1 plus 2 into y naught is 1, y naught is 1, y naught dash is also 1. That is 1 plus 2 is equal to 3. So y naught double dash is 3. Similarly, y naught triple dash, x naught y naught double dash, x naught y naught double dash plus 2 y naught dash plus 2 y naught dash plus 2 y naught double dash 2 y naught double dash, right? Plus 2 y naught dash square plus 2 y naught dash square. Now substitute the values. So y naught triple dash is equal to, x naught is 0, y naught double dash is 3 plus 2 into y naught dash is 1 plus 2 into y naught is 1, y naught double dash is 3 plus 2 into y naught dash square, y naught dash is 1 square, so into 1 square, into 1 square, into 1 square. You compare this. This is 0, this is 2 plus 2, 4 plus 6, 10. So y naught double dash, triple dash is 10. Now substitute in the relation, we call this as 2. Call this as 2. Substitute in 2. Substitute in the equation 2. So what do we get? y1 is equal to y naught is 1 plus h is 0.1 divided by factorial 1 is 1 only. So 0.1 into y naught dash is 1 plus 0.1 square divided by 2 into y naught double dash is 3 plus 0.1 cube, 0.1 whole cube divided by into 3 plus 0.1 whole cube divided by 6 into y naught triple dash, that is 10 plus etc. Now if you compute this carefully using calculator, you will get 1.1166. 1.1166. So I got the value of y at x is equal to 0.1, that is y1 as 1.1166. Similarly, I have to calculate the value of y at x is equal to 0.2 and 0.3 and then apply Milnes predictor and corrector method to find the value of y at x is equal to 0.4. Okay. Now, to get y2, I need to fix n is equal to 1 in 1. So, I just replace here only. Put n is equal to 1 in 1. Put n is equal to 1 in 1 to get y2, this value. And then put n is equal to 2 to get y3 in 1. So, what happens? So, all knots will become 1s. That's all. So, y2 y2 is equal to y1 plus h by factorial 1 y1 dash plus h square by factorial 2 y1 double dash plus h cube by factorial 3 y1 triple dash and so on. So call this as equation number 3. Equation number 3. Okay. Then you calculate these y's. These y's. Now x1 y1 dash is x1 into y1 plus y1 square. So x1 is 0.1 into y1. y1 is this 1.1166. 1.1166 plus y1 square. y1 square is 1.1166 square. So what is the answer here? So y1 dash is equal to, if you simplify, if you can compute carefully, 1.3584. So 1.3584. 1.3584. 1.3584. Okay, so next, y1 double dash. y1 double dash is x1. y1 double dash, y1 dash. y1 double dash, x1 y1 dash plus y1 plus y1 plus 2 into y1 into y1 double dash, y1 dash. Okay. Now substitute the values now. So this is equal to x1 is 0.1, y1 dash is here 1.3584 plus y1 is 1.1166 plus 2 into y1 dash plus 2 into y1 1 point, I can use bracket, 1.1166 1.1166 into y1 dash. y1 dash is 1.3584. 1.3584. So if you compute using calculator, you get y1 double dash is equal to 4.2860. 4.2860. Okay. Now lastly, y1 triple dash. So I need to compute now y1 triple dash, and this is x1 y1 double dash, x1 y1 double dash, right? x1 y1 double dash plus 2 y1 dash plus 2 y1 dash plus 2 y1 double dash plus 2 y1 double dash plus 2 y1 dash square plus 2 y1 dash square. Now let me substitute the values. So this is equal to x1 is 0.1 into y1 double dash is 4.2860 plus 2 into y1 dash is 1.3584 plus 2 into y1. y1 is 1.1166 right? This is continued into, and this is bracket into, that is into, then y1 double dash 4.2860 plus 2 into y1 dash. Y1 dash is 1.3584 square. 1.3584 square. 1.3587. So if you carefully compute, you get y1 triple dash, y1 substitute in 3. Substitute in 3. Substitute in equation 3. So get y2. So y2 in terms of y1 is 1.1166 plus 0.1 divided by 1 into y1 dash 1.3584 1.3584 1.3584 then plus h square 0.1 whole square divided by 2 into y1 double dash. Y1 double dash is 4.286 then plus 0.1 whole cube 0.1 whole cube divided by 6 into y1 triple dash y1 triple dash, okay, the numerical value so y1 triple dash is this. Okay, I will write here. Carefully calculate. Y1 triple dash is 16.407. 16.407. 16.4073. So this is 16.407. So if you calculate using your calculator carefully, you get y2 1.2766. 1.276. So I got the value of y at x is equal to 0.2 as 1.2766. So lastly, I have to compute by using Taylor series method value of y at x is equal to 0.3. So to get y3, I need to fix n is equal to 2 in 1. 2 plus 1, that is 3. So you get y3 in terms of y2 so I get y2 plus h by factorial 1 y2 dash h square by factorial 2 y2 double dash h cube by factorial 3 y2 triple dash and so on. So call this as equation 4. Okay, so calculate this y1 dash. Okay, now y2 dash is x2 into y2 square. y2 dash, I need to calculate y2 dash. y2 dash is x2 y2 square, right? Now let us substitute here. Let us substitute. x2 is 0.2. x2 is 0.2. x2 is 0.2 into y2 is 1.2766 plus y2 square 1.2766 square. So if you compute, you get y2 dash is equal to y2 dash is equal to, if you compute carefully using your calculator, you get 1.8850. 8850. The similarly, I have to calculate y2 double dash. y2 double dash is equal to x2 y2 dash. x2 y2 dash plus y2 plus y2 plus y2 y2 into y2 dash. 2y2 into y2 dash. Okay. Now, substitute here. So x2 is 0.2. x2 is 0.2. y2 dash 1.8850. 1.8850. 8850. Look at here. x2 is 0.2. y2 dash is 1.8850 plus y2 is 1.2766. 1.2766 plus 2 into y2 is 1.2766 into y2 dash is 1.8850. 1.8850. 1.8850. Close. 1.8850. So if you compute carefully, you get y2 double dash 6.4663. 6.4663. 6.4663. That is your y2 double dash. Okay. Now y2 triple dash. y2 triple dash will be x2 y2 double dash. x2 y2 double dash 2 y2 dash 2 y2 double dash y2 double dash 2 y2 dash square 2 y2 dash square. Now let us substitute the values. So x2 is 0.2. x2 is 0.2 into y2 double dash 6.4663. 6.4663 4663 plus y2 double dash plus 2 into y2 dash. y2 dash is 1.8850. 1.8850. Then 2 into y2. y2 1.2766. 1.2766 into y2 double dash 6. This is 6.466. 6.4663. Then plus 2 into plus 2 into y2 dash square 1.8850 square 1.8850 square. Okay. If you calculate this, y2 triple dash is 28.455. So if you calculate, you get 28.455. Okay. 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 Now substitute in 4. Substitute in 4. So y3 will be y3 in terms of y2 is 1.2766 plus 0.1 into y2 dash 1.8850 1.8850 plus 0.1 whole square by 2 into y2 double dash 6.4663 6.4663 then 0.1 whole cube by 6 into y2 triple dash 28.455. So if you carefully calculate using calculator, you will get the value of y at x is equal to x3, that is y3, is equal to 1.502. 1.502. So this is 1.5021. Now I have to calculate value of y at x is equal to x4, 0.4, x4 that is equal to 0.4 using Milne's predictor and corrector method. Now, so far what we have done, we have only determined the required previous values to apply Milne's predictor and corrector method. So let me write the Milne's predictor formula. The last equation is 4. Y dash is x into y plus y square. So take y outside, common factor, y into x plus y. Y dash is equal to f of x comma y. So f of x comma y is y into x plus y. Okay. So Milne's predictor formula. That is y4 p is equal to y0 plus 4 into h divided by 3 into 2 into f1 minus f2 plus 2 into f3. Okay. Close the bracket. So call this as equation. Next equation, I think it is 1. Equation number 4. Okay. So what is f1? F1 is f of x1 comma y1. What is x1? x1 is 0.1 now. F of 0.1 comma 1.1166. Apply the definition. So this is equal to y into x plus y. Y into x plus y. So 1.1166 into 0.1 plus 1.1166. So this is equal to, if you carefully simplify, you get F1 1.358 1.3584. Okay. Now similarly, F2 is F of x2 comma y2. x2 comma y2. This is f of x2 is 0.2, y2 1.2766. Apply the definition. This is y into x plus y, 1.2766 into 0.2 plus y, 1.2766. So this is equal to, if you carefully simplify, calculate, you get the value f2 equal to 1.8850. 1.8850 up to 4 places of decimals. So calculate f3 similarly. f3 is f of x3 comma y3. This is equal to f of f3 x3 is 0.3 comma y3 1.5021. Okay, apply the definition. So this is y into x plus y, 1.5021 into 0.3 plus 1.5021. So if you compute, calculate this carefully, you get y3, f3 is equal to 2.7069. 2.7069. Okay. We shall substitute these values in phi. Substitute in phi. Substitute these f's in the equation phi. So what do we get here? In phi, so therefore phi implies y for p is equal to y naught. Y naught is 1. Y naught is 1 plus 4 into h, 4 into 0.1, h is 0.1 here, divided by 3 into 2 into f1. 2 into f1. Okay. f1 is 1.3584. 3584 minus f2. Minus f2, that is 1.850 plus 2 into f3. f3 is 2.7069. 7069. Close the bracket. So if you calculate using calculator, you get f4p 1.8327. 8327. So the predicted value is predicted value of y at x is equal to 0.4 is 1.8327. Okay. Now I have to correct this. Let me correct this using Milne's character formula. So let me write Milne's character formula. Milne's character formula. Milne's character formula. So that is given by y4c is equal to y4c is equal to, so this starts from y2 plus h by 3 into f2 plus 4 f3 plus f4p plus f4p. So all this as equation number 6. Okay, what is f4p? f4p is f of x4 comma y4p. y4p is this. So this is equal to f of x4. x4 is 0.4. x4 is 0.4. x4 is 0.4 comma y4p 1.8327. 1.8327. Now apply the definition. So this is equal to 1 point y into x plus y, that is 1.8327 into 0.4 plus 1.8327. So if you calculate using calculator, you get y4p is equal to 4.0918. 4.0918. Now substitute in 6. Or 6 implies y4c is equal to y2 is 1.2766 plus h by 3 0.1 divided by 3 into f2 is 1.8850 then plus 4 into f3 is 2.7069 plus f4p is 4.0918. f4p is 4.0918. Okay. So if you compute carefully, y4c corrected value is equal to 1.8367. 1.8367. Now let me fine tune this by considering this itself as the y4p and repeating the same procedure. Okay. I don't require this. Okay. So this is my f2. Okay. Now first iteration. Let y4p be equal to 1.8367. So f4p is f of x4 comma y4p is equal to f of 0.4. y4p is now 1.8367. Now apply the definition. This is 1.8367 into 0.4 plus 1.8367. So if you calculate this, you get 4.108. 4.108. Okay. Now again use it in 6. Therefore 6 implies, equation 6 are substituting in 6. 6 implies y4c is equal to 6 implies y4c is equal to everything same except the last value 1.2766 plus 0.1 divided by 3, 0.1 divided by 3 into 1.8850 plus 4 into 2.7069 plus F4P. This F4P 4.108. So if you carefully calculate, you get F4C in the first iteration as 1.8372, 1.837. Now compare this y4c with this y4c. There is a difference. So let us consider second iteration. For second iteration, let me do it. Second iteration. Second iteration. Let y4p is equal to this 1.837, 1.837. Now calculate F4P. F4P is equal to F of x4 comma y4p. This y4p. So this is F of 0.4 comma 1.8372. So apply the definition. So this is 1.8372 into 0.4 plus 1.837. So if you carefully compute, y4p will be in this case 4.1101. 4.110. Okay. So 6 implies equation number 6 implies substituting in 6 implies y4c is equal to everything same. Only thing this value will change. 1.2766 plus 0.1 divided by 3 into 1.8850 plus 4 into F3. F3 is this 2.7069 plus F4 So if you calculate carefully using calculator, you get 1 point, second iteration 837. Okay, still there is a difference. First iteration iterated value of y is 1.8372. Second one is 1.8373. There is a difference in the fourth decimal place. So still we can refine this. So in the third, considering third iteration. So third iteration. Third iteration. Select y4p is equal to 1.837. Let y4p is equal to 1.837. 1.837. Okay. Okay. So therefore, f4p is equal to f of x4 comma y4p. So f of x4 is 0.4, y4p 1.837. So apply the definition. This is 1.8373 into x plus 1, 0.4 plus 1.833. You calculate carefully, you get y4p is equal to 4.1105. 4.110. So therefore 6 implies, or substitute in 6 implies 1.276 is everything same, 0.1 by 3, these also same, 4 into 2.7069 same, only the last value will change, 4.110. So if you compute this, you get 1.8373 again. 1.8373. So I can notice that second iterated value is 1.8373. Third iterated value is also 1.8373. Since the second and third iterations are the same up to 4 decimal places, we conclude that the value of y at x is equal to 0.4 is 1.8373 by Milne's predictor and corrector method. So we can conclude like this. Since the second and third iterations are the same up to 4 decimal places. 4 decimal places. Up to 4 decimal places. So y4, that is y at x is equal to x4, that is y at x is equal to 0.4 is equal to 1.837. So I got the value, approximate value of y at x is equal to 0.4 by Milne's predictor corrector method as 1.837. 1.837. 837. Now this completes this problem. So whenever the values are not given, previous values, to apply the predictor corrector method, we can calculate those missing values by single step methods, either by Taylor series method or by Runge-Kutta method of fourth order or by modified Euler's method. So normally they mention the method in which is to be employed to find those required values of y for the given values of x. Okay. If Taylor series is mentioned, you have to apply Taylor series method. If Runge-Kutta method of fourth order is mentioned, you have to apply Runge-Kutta method of fourth order to obtain those values, or if the method is specified as modified Euler's method, then you have to apply modified Euler's method to compute those values. Okay. So now let me consider another problem. Let me consider another problem. Problem number 4. Solve the differential equation. Solve the differential equation. Differential equation y dash plus y plus x into y square is equal to 0, where initial condition with initial values of y naught is 1, y1 is 0.900, y2 0.8066, y3 0.722, corresponding to the values of x naught is equal to 1, 0, x naught is equal to 0, x1 is equal to 0.1, x2 0.2, x3 0.3. By computing the value of y corresponding to the value of x at point 4. Applying Milnes predictor character method. So here in this problem, the required previous values are given in the problem, it's in the data itself. Okay. So we shall first list what is given in the problem. So f of x comma y, so you have to calculate it. Y dash is equal to minus y minus x into y square, or minus of y into 1 plus y, xy. So fxy is minus y minus x into y square, right? So this is equal to minus y into 1 plus x into 1. Y into minus y into 1 plus xy. And what is given? X naught is given to be 0. Corresponding value of y naught is 1. Then x1 is 0.1. Then corresponding value of y is 0.9008. Then x2 is 0.2. Corresponding value of y2 is 0.8066. Then x3 is 0.3. Corresponding value y3 is 0.722 and x4 is 0.4. x4 is 0.4 and y4 we need to calculate. Okay. So let me h is 0.4. Very simple. H is 0.4. Now let me write down the data and then apply Milne's predictor calculator. So given f of x comma y is equal to minus y into 1 plus x into 1. Okay. X naught is 0, y naught is 1. X naught is 0, y naught is 1. x1 0.1, y1 0.9008. Then x2 0.2, corresponding value y2 8.8066. x3 is 0.3, corresponding value y3 is 0.720. x4 is 0.4 and this is where we need to calculate using Milne's predictor corrector method. Okay. So h is very clearly it is 0.1. H is 0.1. Correct the Milne's predictor method. Milne's predictor method. Milne's predictor method. Formula. Predictor formula. What is the Milne's predictor formula? Y4P is equal to y0 plus 4 into h divided by 3 into 2 into f1, 2 into f1 minus f2 plus 2 into f3. Call this as equation number 1. Now let me substitute for f1, f2, f3. Calculate or substitute. f1 is f of x1 comma y. So this is equal to f of x1 is 0.1, x1 is 0.1, comma y1 0.9008. After the definition, it is minus y minus 0.900 into 1 plus 0.1 into 0.9008. Okay. If you carefully compute, you get f1 minus 0.9819 minus 0.9819. Similarly, f2, f of x2 comma y2 is equal to f of x2 is 0.2, y2 0.8066. So apply the definition. So this is minus y into 1 plus xy minus 0.8066 into 1 plus 0.2 into 0.8066. So if we calculate, we get F2 is equal to minus 0.9367. Now lastly, F3 is F of x3 comma y3. Okay. So this is equal to F of 0.3 comma 0.722 0.722. Apply the definition. So this is minus 0.7220 into 1 plus 0.3 into 0.722. So if you carefully compute this, you get minus 0.8782 minus 0.8782 minus 0.8782. Okay. So now I have to substitute in one. Substitute in the relation 1. So I get y4p is equal to y0 is 1 plus 4 into h is 0.1 divided by 3 into f1 2f1. So 2 into f1 is minus 0.9819. Then minus f2 means this is plus 0.9367937 plus 2 into minus f3 2 into f3, that is minus 0.8783. Okay. Okay. So if you calculate carefully, you get y4p 0.y4p is equal to 0.6288. Okay, now let me correct this value by applying Milne's character formula. So Milne's character formula. So it is given by y4c is equal to y2 plus h divided by 3 into f2 plus 4 f3 plus f4p where f4p is f of x4 comma y4p. So this is f of 0.4, x4 is 0.4 comma y4p is this 0.6288 0.6288. 6288. Now apply the definition. So this is minus 0.6288 into 1 plus 0.4 into 0.6288. So Y4P, if you compute carefully using calculator, you get minus 0.7869. Minus 0.7869. Minus 0.7869. Now substitute, you call this as equation number 2. Substitute into in the relation to so take place here. So Y4C is equal to Y2. Y2 is 0.8066 plus H by 3 0.1 divided by 3 into F2. F2 is minus 0.9367 plus 4 into F3 plus 4 into F3. F3 is minus 0.8783 plus F4P. F4P is minus 0.7869 minus 0.7869. Close. So if you compute this, you get 0.6320. 0.6320. This is the corrected value. So we can still refine this by considering this itself as the Y4P and repeating it. So I will work out here. First iteration, let Y4P be equal to 0.6320. Now calculate F4P. F4P is F of X4 comma Y4P. So this is F of 0.4 comma 0.6320. So apply the definition, you get minus 0.6320 into 1 plus 0.4 into 0.6320. So if you calculate this using calculator, you get F4P is equal to minus 0.7917. Minus 0.7917. Now 6, you call this as 2. 2 implies, substitute into R simply. 2 implies Y4C is equal to Y2. Okay, yes. Y2 0.8066 plus 0.1 divided by 3 into F1. F1 is minus 9367. F1 is F2 is minus 0.7869. 9367 plus 4 into F3 is okay, F2 is 0. Point minus point 8783 plus F4P is minus point 7917. So if you compute carefully using calculator Y4C, you get for the first iteration 0.6318. 0.631. Now compare this with the previous value of Y4C. 6320, 6319. There is a difference. So you need to fine tune this once again by considering iterating once again. That is second iteration. Let Y4P is equal to 0.6318. Now compute your F4P, first iteration, second iteration, F1, X4, Y4P. So this is F1 0.4, X4 is 0.4, Y4P 0.6318. So by applying definition, this is minus 0.6318 into 1 plus 0.4 into 0.6318. So if you compute this carefully, you get F4P minus 0.7914 minus 0.7914. Now let us use, so therefore 2 implies same thing. Y4C is equal to Y2 is 0.8066 plus 0.1 by 3 into F2. F2 is minus 0.9367. That is your F2 0.9367 plus 4 into F3. F3 is 0.8783 minus 0.8783, then plus F4P, that is minus 0.7914. So the second iteration F4C, if you calculate this using calculator carefully, you get 0.6318. Now just observe, second iterated value, first iterated value are the same up to 4 places of decimals. So we conclude that value of y at x is equal to x4 is equal to 0.4 is 0.6318. So we write here, says the first and the second iterations are the same up to 4 decimals, up to 4 decimals, up to 4 decimals, up to 4 decimals, y4 is nothing but y at x is equal to x4 is nothing but y at x is equal to 0.4 is equal to 0.6318. 0.6318. So the value of y at x is equal to 0.4 by Milnes predictor and corrector method up to 4 places of decimals is 0.6318. 0.6318. I will stop here, and as per your syllabus content, another predictor corrector method, namely Adams-Bashforth method, is only left over, that I will consider in my next class. Thank you.